Hello friends and welcome to first tutorial of object-oriented programming in Python. So first of all, why do we use object-oriented programming? The answer to that is it provides us a modular structure, and due to that it is easy to handle and more presentable. So let's get started with object-oriented programming in Python. So the first thing to remember is that in the object-oriented programming, variables are known as instances and functions are known as methods. So now let's create our first class, and it is as simple as typing class and after that writing its name. Let it be students, and after the name of the students we have to write or add a colon. Now that our class is created, we can add different methods which we call functions in simple programming language. So we can add different methods, and the methods are created the same way as we have created the functions in simple programming language. So after defining def, we have to write the name. Let it be jump, and you guys can see the self argument is automatically assigned to the method. I will tell you about it later. So in the function or method, you have to print jump, and this is our class. This is a basic class, nothing complex. So after the class is created, we have to add some objects in the class. Let's say child1 equals students and empty parentheses. Now by typing it, what we have done is we have made child1 an object of students class that we have just created above. Now here if I write print and in the empty parentheses I type child1 and run the code, you will see that we have students object. That means it is the object of students class that we have just created. So now let's remove this line and have a look at the jump method we have created. So if we call it simply as we used to call it in simple programming language, you guys can see we get an error. So the way you call a class method is by typing the name of the class dot the method, and if I now run the code, you guys can see we get an error. So if I read it, it says jump missing one required positional argument self. So we have to add the name of the object that we have created, which is child1. Now if I run the code, you will see it works perfectly. Now let's remove this method and I will show you another method which is init method. So def init, and the specialty of this method is that it runs itself. We don't have to call it outside the class. It runs itself as the object is created. So let's move this line students.jump child1, and now let's add some arguments in our init method, which will be name, age, and let's say marks. Now in this method I will type self.name equals name. Let's copy that and I will paste it 3 times as we have 3 arguments, and replace the name with the respective arguments. So what we have done here is self.name equals name. That means self, which is the object itself, and object's name is name, object's age is age, and object's marks are marks. Now we can assign specific values for specific objects for the arguments that we have created. So after the self, first argument is name, which is Mike. and his age is 17 and he got, let's say, 98 marks. So if I run the code, you will see nothing happens. So for that we have to add another statement, which is print statement, and it will be print name, age and marks. Now if I run the code, you will see we get the name, age and marks according to the order that we have set. So as we have set this child1 object, the init method runs and give us the result, which is the name, age and marks. Let's create another object which will be child2, and I will change the values of these arguments. Let's say its name will be Bob and his age will be 16 and he scored, let's say, 95. If I run the code now, you will see the values have changed, but we have to change the name of the object too. So we get Mike and Bob. You may have noticed that we have written only one print statement in our code, then why we have got two lines of result? It is because after the object is created, the init method runs and give us the result. As we have created two objects, the init method runs two times and give us the result of two lines. So as a start, as I have said that object-oriented programming is manageable and presentable, you guys can see the class that we have created can be just minimized into one line. This is the second part of object-oriented programming in Python. So in this video, I'm going to show you the difference between class variables and instance variables. So to understand the difference, let's write here print and in the empty parentheses child1. Let's change the name of these objects to s1 and s2. Now if I write here s1.name and now run the code, you will see its name is Mike. Now how do we access this name variable? Is because it is the variable of an object or an instance which we have created in the class init method by using self argument. So this was one method of creating instance variables by using self arguments. The other way of creating instance variables is by typing the name of the object s1 dot subject, which is the name of the variable that I want to create, and is equal to its value. If it is a string, then it should be in double quotation marks. Now to access it, I will write here print and in the empty parentheses s1 dot subject. Now we have added a new attribute in s1 object, which is subject. So if I run the code, it should print out maths. So let's check out the code if it is working perfectly or not. So if I run the code now, you guys can see it print out maths. Now let me show you a trick to check the attributes of a specific object. That is to write underscore underscore dict underscore underscore. So now if I run the code, you will see we get name, age, marks and subjects and their values. The name, age and marks are created in the class in init method and the subject is just created outside the class. Now name, age, marks and subject, these all are instance variables. So I hope that instance variables are clear to you. And now let's move on to class variables. But before that, let's add some changes to our class students. Let's change marks argument to fee and self.fee equals fee. Now creating a class variable is as simple as typing the name of the variable and after that its value. In my case it is add fee and its value is 1.10, which is 10%. So after that, let's create a new class method which will be def add underscore fee, and in here I will add some changes to fee. So I will write here self.fee equals self.fee multiply by firstly, let's comment out this add fee variable that we have just created, and I will write the value of the add fee here, and there's a spelling mistake. So now let's change these marks values to fee. S1 has 98,000 fee and S2 has 95,000 fee. Now if I want to increase the fee of S1 student, then I have to write here s1.addFee empty parentheses, and you guys can see here if I print s1.fee, it gives out an increased value which is 10,780, but it is giving us a float number, so let's change it to int and now print the code, and you guys can see it is working perfectly. Now let's do the same for S2 student. You guys can see that the value of S2.fee is 9,500 without any increment. So if I add increment to S2 fee by writing S2.addFee empty parentheses, you guys can see now that the S2 fee has changed to 10,450. Now let's work with the class variable that we have created and commented out. Let's remove this comment, and you guys can see the class variable is having same name as class method. So let's change the name of the class method. I will change the name of the class method from add fee to, let's say, new fee. And I will do the same changes down there. Now if I replace this 1.10 with add fee variable, you guys can see we get error. Why is that so? Because to access a class variable we have to give reference, that can be a class or self. So we have to write students dot add fee, and you guys can see the issue is resolved. We can do the same by typing self dot add fee, and that should work the same. Now let's remove this line, and if I run the code, you guys can see we get 9,500, which is the fee of student 2. Now let's add increment to student 2 fee by typing s2 dot new fee empty parentheses, and if I run the code now, you guys can see we have the same value as the previous one, which is 10,450. Let's remove this, and I will write s2 dot new fee equals, let's say, 50,000. So this new fee is instance variable of object s2. So now if I print s2 dot underscore underscore dict underscore underscore and now run the code, you guys can see we get name, age, fee and new fee as our attributes of s2. If I remove this line and now run the code, you guys can see we have removed the new fee from our attributes list. Same we can do with our class, which is students, and if I run the code, you guys can see we have add fee as our class variable, and its value is 1.10, which is equal to 1.1 as we have set above. Now I will write here s1 dot new fee, and after that I will write here print s1 dot fee. Now if I run the code, you will see that our fee has increased. So that means our programming is working perfectly. Now I want to calculate the number of students in a class. So for that, let's create another variable which will be number of students, and its value will be 0. And after that, let's move to init method, and I will write here number of students plus equals 1. But you guys can see we get error as we have not set a reference to our class variable. So I will write here students dot number of students plus equals 1. So what it will do? Is it will add 1 to number of students as soon as an object is created. Now let's print the number of students by typing students dot number of students. If I run the code, you guys can see it gives us 2 as we have created 2 objects above. Let's copy it and I will paste it here, and if I run the code now, you will see firstly we get 0 and after that we get 2 because firstly we haven't created any object. So let's create another object and I will change the name and some values, and let's copy this print statement and paste it below. If I run the code now, you guys can see we get 3 as output. So that means our program is working perfectly and we have created another class variable which is number of students. There is an important concept that I want to share with you is firstly I will write here s1 dot add fee and you guys can see its value is 1.10. If I run the code, you guys can see we get 1.1. So I will copy it and I will paste it 3 times and I will change the name of the objects and it will be s2 and 1 will be students. If I run the code now, you guys can see the value is same for all of them, but we can also change for specific object. Let's suppose I want to change the add fee value for student 2 object. So I will write here s2 dot add fee equals, let's say, 1.50. So that has changed the add fee value for student 2. If I run the code, you guys can see the student 2 add fee value is 1.5. So now let's remove this line and run the code again and you will see we get 1.1 and 1.5 as output. So let's change this with the underscore underscore dict underscore underscore for both of the print statements. So now if I run the code, you will see we have addition of an attribute for s2 object which is add fee. That means if we change a class variable's value, it becomes instance variable. Now let's move these print statements and I will write here s2 dot new fee and after that I will write here print s2 dot fee and it should increase the value of fee, and you guys can see after running the code its value is 14250. So I hope you understand both the class variable and instance variable and how to deal with them. In this video we will cover class methods. First of all, methods are of 3 types: class methods, static methods, and regular methods. Regular methods are the methods which take self or instance as an argument. Like here we have new fee method as a regular method as it is taking self as an argument. Now let's move on to class methods. A class method is simply created by adding a class method decorator above a method, and after that we will create a simple method. But the difference between a regular method and a class method is that class method takes class as an argument and regular method takes self or instance as an argument. Now let's name our class method, which will be raise underscore fee, and if I close the brackets you will see that class is automatically taken as an argument and CLS represents the class. So this is one argument. We can also add another argument which will be, let's say, add fee, and here I will write class dot add fee equals class dot add fee plus new amount. Let's change the name of the argument to new amount. So this is our class method. Let me explain what it does. Actually, you guys can see that class students has add fee variable which is equal to 1.10. So what I am doing here is I am taking that variable and I am making it equal to 1.10 plus the new amount that we will give when the method is called. So let's move on. So now if I want to apply a raise to student S1, I will write here S1 S1 dot raise fee, and in the empty parentheses I will write here 200. Let's change the value of add fee variable to 500, and if I come back here and if I print the students dot add fee, we will see that its value is 700, as it added the original value and the value that we have given to make a total of 700. Firstly, let's remove this multiplicative sign and add a positive sign. Now I will remove this line, and here I will write s1 dot new fee, which will run the regular method which is new fee, and now I will print s1 dot fee. If I run the code, you will see its value is 10,500. The original value of the fee of S1 is 9,800, and if we add 700 to 9,800, it will make a total of 10,500. And one more thing, you might have noticed that raise fee is a class method and we have called it by the reference of student1, which is an object. So this was the difference between class method and a regular method, that even the class method is called by the reference of an object, it affects the whole class as it affected the add fee variable. So the class method is for whole class and affects the whole class, where the regular method is only for an object, as it takes only the self or an instance argument, where the class method takes class as an argument. In the previous video, we discussed about class methods. So in this video, we are going to discuss about static methods. Static methods are more similar to simple functions that we have discussed in simple Python programming language. The difference between those functions and the static methods is only the decorator static method, and pretty much everything is same except the decorator. So let's start by creating a static method. Static methods are created the same way we have created the class methods. So I will add the decorator static methods, and after that we have to define a method, and I will name it anything. I will name it print something, print underscore something, and in the empty parentheses I can choose any argument, or if I wish I can leave it empty. So I will write here string, without G so that it might not be confusing. We will try both ways, firstly without G and secondly with G. So string without G, and in this method I will write print and in the empty parentheses I will write string without G. So now it's time to call the method. Let's remove this print statement. I will write here students dot print something, and in the empty parentheses my name is Mike. So this string that we have written, my name is Mike, if I place it instead of string in the print something method, the result would be same. After running the code, you will see that my name is Mike is the output. So that was our test without G. Let's try with a G. Now let's run the code and we will see that the result is same. So in this video, I told you about static methods and how they are created and executed. In the previous video, we discussed about static methods. So in this video, we are going to discuss about inheritance and subclasses. So for that, let's create another class and I will name it teachers. But before that, we have to do some changes in the previous class name, and I will change the name of the previous class to staff, and that name will also be changed within the class and the objects of this class. Now let's name the next class, which will be teachers, and in the empty parentheses I will write staff to show that it is a subclass of the class staff. Now as we have done in the previous class, that we have created the init method first, same we will do here. I will write here def underscore underscore init underscore underscore and self in the empty parentheses. Now I will add other arguments along with the self argument, which will be name, age, fee and subject. Now instead of writing self.name equals name, self.age equals age and self.fee equals fee, I will write here super and empty parentheses dot init, and in the empty parentheses I will write name, age and fee. What does that mean? That means we don't have to assign the name, age and fee arguments again and again, as they have been assigned in the previous class, which is staff. So super.init means that it will adopt name, age and fee arguments from the superclass, which is staff, and the name, age and fee arguments are going to be adopted from the staff init method. So there is one more new argument, which is subject. So we will write here self dot subject equals subject. We are writing it here because it is new and we haven't added it in the previous class, which is staff. Now let's add the value of new argument subject that we have just created, but you will see that these values are highlighted with yellow. That means there is an error, we shouldn't add these values. Why is that so? It is because the subject argument that we have just created is only for the class teacher and it is not for the class staff. The object created here is created with the reference of staff. So let's change the class name to teacher and you will see that the problem is resolved. So now let's change the name of the objects from S1 and S2 to T1 and T2. and you have to add the colon sign after the name of the class. So let's add the colon sign, and now I will write here print t1 dot subject, and if I run the code you will see that its subject is maths. And if I change the object to t2, and it will change the subject, which is English. Now I will add a class variable to the class teacher as we have added it in the class staff. In the class staff, the add underscore fee variable has the value 500, but I will create add underscore fee variable with the value of, let's say, 200. Now let's change the name of the class for T2, and its class will be changed from teacher to staff. And let's move the English subject as it is not the part of the staff class. So now, to understand the concept or to check if we can inherit the methods of the parent class also, in this case it is the class staff, I will write here t1 dot new fee, where new fee is the method of class staff, which is the parent class, and t1 is the object of class teacher. So t1 dot fee, if we print the t1 dot fee, you will see that it is increased to 10,000, where the current value of the fee is 9800 or 9800. If we add 200 to the 9800 or 9800, it will make total of 10,000. Same we can do with the t2 object, and its value will also increase, but with the reference of the value in the class staff. If we change the add fee value in the class staff, you will see that its value increases to 10,100. So that means that we can inherit the methods from parent class. Now let me show you some more things related to the inheritance and subclasses. Firstly, let's remove these lines, and I will write here print is instance, and in the empty parentheses I will write t1 comma staff. What it will do is it will check if the t1 object is the instance of class staff, and it is true. Why is it true? Because t1 is the object of class teacher, and class teacher is the subclass of class staff. So indirectly t1 is the instance of class staff. So now let's change the name of the object from t1 to t2 and run the code. You will see it is also true because t2 is the instance of class staff. So let's see if it is the instance of class teacher. You guys can see it is false. So let's change is instance function to is subclass, and it will check if the first class is the subclass of the second class. So let's check if the staff class is the subclass of teacher class. You guys can see it is false. So now let's check if the teacher class is the subclass of the class staff. You guys can see it is true because class teacher is the subclass of class staff. So in this video I told you about inheritance and subclasses. In the previous video we discussed about inheritance and subclasses. So in this video we are going to discuss about special methods, dunder methods or magic methods. You may call it as dunder methods as they have double underscores, as we have underscore underscore init underscore underscore method. So firstly, let's create a student class, and I will create an init method and I will assign some arguments or attributes like name, age, fee, and subject. Now self.name equals name. Now I will copy it and paste it 4 times. Now let's change the name of the attributes. Age, fee, and subject. So this was our class. Let's create an object now. So to create an object, I will write here s1 equals students, and in the empty parentheses in double quotation marks Mike, which is name, comma, age, which is 16, and fee, which is, let's say, 10,000, and the subject is, let's say, science. Now the object is created. Let's check if it is working perfectly or not. I will write here print, and in the empty parentheses I will write s1.name. If I run the code, you will see we get Mike, which is the name of s1. So that means our code is working fine and we have successfully created the class and the object. So now let me show you the magic of the magic functions or magic methods. As you guys can see here, we have underscore underscore init underscore underscore. It is an example of magic method or dunder method. Let me show you an example of another dunder method. So for that, I will write here print, and in the empty parentheses s1. Now if I run the code, you will see that we get this result, which is hard to read and not user friendly. So if I add dot underscore underscore repr underscore underscore with an empty parenthesis and now run the code, you will see we get the same result. Why is that so? It is because we haven't defined the repr method in our class. So let's remove that and go back to class and define the repr method. So I will write here def underscore underscore repr underscore underscore and in the empty parenthesis self, and here I will write return, and now in the double quotation marks students, and in the empty parenthesis I will add 3 curly brackets, each surrounded by single quotation marks. So I will write here dot format, and in the empty parenthesis I will write self dot name. So self dot name, and let's reduce the number of curly brackets for now, and you will see the issue is resolved as we have one curly bracket in which self dot name will be placed. So if I run the code now, you will see we get students and in the empty parenthesis Mike, which was not the result before adding the repr method in the class. So now let's increase the number of attributes here, that will be 4, and let's increase the number of curly brackets that we have reduced from 3. But firstly, let's change the name of the attributes: name, age, fee, and subject. Now let's increase the curly brackets. Now if I run the code, you will see we get the same output that we have given to it as input while creating the object. Now if I comment out these lines and now run the code, you will see we get the same old output which is hard to read and is not user friendly. So if I remove these comments and now run the code, you will see we get the same easy to read and user friendly output. So that was it for REPR method. Now is the time for STR method. So I will copy this underscore underscore REPR underscore underscore method and I will paste it down below. Now let's change the name of the function or method from REPR to STR. So now let's remove the S from students in the STR method, and if I run the code, you will see we get the result with respect to STR method, as we have removed the S from STR method. And in the print statement, let's add the STR method and run the code again. You will see we get the same result, but if we add REPR method here, we will get the result with respect to REPR method. Now if I remove the str method from the class and add the str method in the print statement, you will see we get the result with respect to REPR method, as the str method uses the REPR method as a fallback. And if I remove the REPR method, you will see we get the same old, hard to read and non-user friendly output. Now if I remove the REPR method from the class and use the REPR method in the print statement, you will see we get the same hard to read and non-user friendly output. But if I use the str method in the print statement, we get the user friendly and easy to read output. There are many more special methods and dunder methods. So to demonstrate a few, let's create an other object and let's change its attributes. Let its name be Bob, his age be 17, his fee be 12,000 and his subject be computer. And let's change the name of the object to S2. Now you may have noticed that if we add the integers and if we add the strings, both behave differently regarding their addition. So you will see if we add 1 plus 2, it will give us 3, which can also be achieved by typing int dot underscore underscore add underscore underscore and in the empty parentheses the digits to add, which will be 1 and 2, and if I run the code you will see the answer is 3. Now here the underscore underscore add underscore underscore is also an example of dunder method. Now let's copy that and paste it again, but instead of 1 and 2, let's change it to a and 2 in the double quotation marks, which will be a string. If I run the code, you will see that both the integers and the strings behave differently regarding their addition. Same we can do with our objects. So let's create an add method underscore underscore add underscore underscore method in our class, and here I will write return self dot fee plus other dot, let's change it to other object in the argument. So let's change other other object obj dot fee. So this is our add method. Let's comment it out first. And if I write here print s1 plus s2 and now run the code, you will see we get error. Students and students cannot be added, which is unsupported operand. So if I add this add function and now run the code, you will see we get 22,000, which is the sum of both objects fee. So in this way we can derive different logics for the addition of the objects. So this was all about underscore underscore add underscore underscore method. Let's move on to the length function or length method, which will tell you about the number of letters in a string. So let's move this s1 plus s2, and here I will write length and in the empty parentheses Mike in the double quotation marks. If we run the code, it should give us 4, and we can see the answer is 4. So this can also be achieved by typing str dot underscore underscore length underscore underscore and in the empty parentheses in double quotation marks MIKE, which is Mike. And if I run the code, you will see it gives us the same result. And Mike in the double quotation marks dot length also give us 4. But instead, if I write here s1 dot length and now run the code, we will see we get an error. Why is that so? Because we haven't added the length method in our class. So let's add the length method by copying and pasting the add method we have created above. So let's move this line, and instead I will write here length of self, and let's move the other object from the arguments. And now if I run the code, we will see we get an error. It is because I have written in the length method return the length of self, but instead it should be return the length of self dot name. So if I run the code now, you will see s1 dot length is equal to 4, and if I change it to s2 and now run the code, you will see we get 3. So that was all about magic methods, dunder methods, and special methods. In the previous video, we discussed about special methods or dunder methods. So in this video, we are going to discuss about property decorator. So you guys can see here that we have a simple class students in which we have first name and the last name as attributes, where full name methods give us the full name of the object. So let's add an object to our class. S1 equals students, and in the empty parentheses let it be Mr. Bean. I can't guess of another name right now, so let it be Mr. Bean. And down here I will write print, and in the empty parentheses s1 dot email, and I will copy it and paste it total 3 times. And let's change the email to full name and then first name. You guys can see we have an empty parenthesis after the full name as it is a method. So if I run the code, you will see we get Mr. Bean at email.com. This is Mr. Bean and Mr. So that means our code is working fine. So let me show you some exceptions now. Let's suppose if s1 dot first name is changed to, let's say, what should it be? Um, Let it be Mike. In the double question marks, we will set it Mike. So if I run the code, you will see we get mrbean@email.com. This is Mike Bean and Mike, which is the first name. So the first name in the email hasn't changed. Why is that so? It is because firstly, when we created the object, it runs the init method and follows the instructions. The init method takes previous first name, while the full name method uses the current full name, which is Mike, and follows its instructions which were given to it in the method. So now to solve this problem, we can also define an email method the way we define the full name method. As the full name method takes the current first name, the email method should do the same. So let's create an email method. I will copy the full name method and paste it below. Let's change the name of the method to email and remove this line, this is, and also the space between the curly brackets. So that would be first name, last name at email.com. So now let's comment out this line in the init method. But before running the code, you have to add empty parentheses in the print statement after the email. So if I run the code now, you will see that our problem is solved. So now you guys might have noticed that we are accessing the full name and the email as a method but not as an attribute. So to access the email and the full name as attributes, we have to add the property decorator above them. So how to add a property decorator? A property decorator can be added simply by typing add property above the name of the function or method. Now by adding the property decorator, we can move these empty parentheses, and if I run the code, you will see we get the same result. Now I haven't added the property decorator for the full name, and if I remove these empty parentheses and now run the code, you will see we get this non-user friendly output. But if I add the property decorator for the full name and now run the code, you will see we get the same result, which is this is Mike Bean. So in this way we can access the method as an attribute. So now let's move this line s1.firstname is equal to Mike, and now I want to set the full name of s1 to, let's say, another name I have to guess. Let it be Bob Richard. Let it be Bob Richard. So s1 dot full name is equal to Bob Richard. If I run the code, you will see we get an error, attribute error, which is can't set the attribute. This problem can be solved by setter and deleter decorators. So to add the setter or deleter method or decorator, I have to write here at full name, which is the method name. So add full name dot setter, that means I have to set at full name, and then the name of the method def full name self, and an argument I will write here, which is name, which we have commented out for now. So first name comma last name equals name dot split, and in the empty parentheses in double quotation marks a space. So what it will do is it will split the Bob Richard in two parts by a space, and it will set the first name Bob and the second name Richard. So I have to assign these first name and last name. Self.first name equals first name and self.last name equals last name. If I run the code now, but before that let's remove this comment, and if I run the code now, you will see we have completely changed the full name of the object. bobrichard@email.com. This is Bob Richard and the first name is Bob. So you have seen that before adding the full name .setter decorator, we were not able to change the name of the object. If I change the Bob Richard to Bob Bean and now run the code, you will see we have completely changed the name again. So in this way, the setter decorator is helpful. So to delete the full name, I have to write here delete del s1 dot full name, not first name, it is full name. And if I run the code, you will see we get an error, which is again attribute error, which is can't delete the attribute. So as we have used the full name dot setter decorator, I will copy this and I will paste here again, but instead of setter I will write here deleter. And now let's move these lines and the argument, and I will write here print name deleted in the double quotation marks, name deleted. And here I have to assign the first and last name again. So self.first name equals none and self.last name equals none. Now if I run the code now, you will see the name is deleted. So this was the last video of object-oriented programming in Python. So I have completed the course, and yeah, that's it for today guys, and I hope to see you again in the next series. And I hope that would be Flask, the web development in Python. I hope so. I will try to upload, but it can be changed. So that's it for today guys. Thank you for watching, and I hope to see you again in the next video.